Hello viewers, welcome to our interview. I, Anupam Vipul from AHIRAVATA, Chief Visionary Officer. We have the luxury of communicating with Barry. So Barry, could you introduce yourself?
Sure. My name is Berry Rutten. I'm the Vice President of Marketing and Sales for CV Global.
Okay, so as you all guys know that we are trying to bring Ron's idea into real world. Basically, Ron had created a very amazing engine and we are trying our damn best to make sure that it sees the light of the day. So Barry is helping us in that regard. So Barry, could you elaborate your side of the deal, so to say?
Sure. Like many people who were exposed to Ron's technology, got very excited. I have a little bit of background in engines, and especially I have several boats. One has an outboard engine, one has an inboard diesel engine. And so when you understand what's possible from this technology, you get very excited. If I was, for example, a boat builder and I had the ability to have the same horsepower in a package that was half the size and weight, it would make the boat perform better. For something like an inboard engine, it would create either a lot more space around the engine to work or for accommodations, or I could have essentially double the horsepower in the same physical space depending on the application. So instead of having the trend right now, for example, is like 4 or 5 outboard engines on the back of a boat, which is kind of crazy because each engine is very expensive, you could have half the number of engines in the same horsepower. So the more I got into it, the more I realized it had very broad applications in a range of industries, and was very scalable from something very, very small to something very, very large. And it had a lot of benefits related to fuel economy, to emissions, to power output, to torque, and things like that. And so it's just to me, it's very exciting, and I think it has advantages that are pretty unique in the industry.
Yeah, so Ron has also talked about that he was also into boat racing very early on, since I think he was a
Right.
baby, he started to use boats. So, and he had like very good memories with him and his father dealing with boats and all that. And he has intuitive understanding of what role power to weight ratio plays into, like, actual boat racing and so to say. So I think you have an actual understanding what these numbers mean, rather than just like, okay, this is a thing, this is a bit better. I think you understand that your boat will go faster. How does that feel? So uh, can you talk about more about your experience at boating? When did you got into it, what age, and like what things you have played into? Because Ron has like a very colored history when it comes to racing. He has raced with everything. So
Right.
provide a bit more context with that regard.
Yeah, Ron and I actually met at our mutual boating club in Seattle, Washington. I grew up on the water in Long Island, New York, so boating and the water was part of my life. And you get into smaller boats. The outboard engine is a pretty critical component of that, but it ends up being kind of heavy. Original engines were, all 2 strokes, and they were kind of dirty. Then the 4 strokes came out. But I've been on boats since I was a kid. I used to do clamming to make some money. And then when I moved out here, we bought a boat with an inboard gasoline engine, which is basically a marinized car engine. And then eventually the boats we have now, one has a 6-cylinder, 370 horsepower diesel, and the other one has 150 horsepower outboard. And I mean, weight is everything in boating, number one. And number two, Ron could probably explain this way better than I can. He's the super technical guy, but the reality is you have to get all this weight up out of the water to have it, right on top of the water. So if we can cut the weight down, number one, or we can improve the torque. A boat is basically like being in a car going uphill in first gear all the time. So a marine engine works way harder than a car engine because it doesn't really have a transmission. And once a car, most of the horsepower of a car or a truck is about getting it up to road speed. Once it's on road speed, it takes a lot less horsepower to maintain it until you actually have to go up a hill. Whereas the marine engine is working way harder. And I remember a quote from the head of engine development for Volvo Penta, who said, "We wake up in the morning thinking about torque, we spend all day working on torque, and we go to bed thinking about torque." And so one of the things that is kind of cool about this engine is it develops a tremendous amount of torque, much more than the same displacement engine. And it maintains that torque over 85-90% of the stroke. So to a marine engine manufacturer especially, that would be extremely attractive.
Yeah, just out of curiosity, I'm not familiar with this term camming. What do you mean by camming to make some early money? I'm not familiar with that.
I'm sorry, what was the word?
Camming. You sort of like you did bit of camming to make some money, like clamming or something.
Oh, clamming. Um, so shellfish,
Okay.
clams,
Okay. Okay.
oysters,
Okay. Okay.
mussels.
Okay. Okay.
So clams, where I grew up, were something that people would eat at restaurants.
Uh-huh.
So they're down in the mud, and so you'd stand on the side of a boat with a big long rake with a basket,
Okay.
and you
Okay.
push that into the water, scoop them up, put them in a bucket, and you could sell them on the dock to a wholesale fish
Okay.
buyer, and then we'd have cash, which as a
Okay.
high school student was very attractive.
Uh-huh, uh-huh. Yeah, you also brought up a very interesting point that I did not think about, that there is no transmission in a boat system. It's literally direct drive. You have your engine, you have your combustion, you have your torque, and it goes into propeller. There is nothing other than that. Maybe if its shaft turns 90-degree, maybe it may have something, but I don't think most of them even have that, right? They are direct shaft driven.
It's just engine to however they transfer the power through the shaft. Either it's a straight shaft, with a regular boat, there's a shaft and a propeller. With an outboard, it's kind of a couple of 90-degree turns to get to the propeller. But that's it. There's one final gear ratio, and that's it.
Yeah, and in this regard, I think it would be more closer to what we deal with when we are talking about EV. They have one motor, one set of gear, and that's it. There is nothing more, no switching. So basically, motor has to generate all the torque required from dead stop to the maximum speed. Okay, so what kind of speed when we are talking about when you are talking about boat? Because again, not a lot of people have boat experience. So talk about speed when we are talking about like it's.
Well, it's all over the map, right? You could have a little 2 horsepower output that basically just moves you along. I mean, for me, we have one boat that's 18 feet with a 150 horsepower engine that probably goes. I'm sorry, I don't do kilometers,
No
but
problem,
it
no
it,
problem.
it probably goes. Top speed is maybe 48 miles an hour. The other boat, which is bigger, heavier, slower, it probably goes 25 miles an hour. But in a larger object, that feels fast,
Okay.
right?
Yeah.
But I mean, boat racing out here, they have something called hydroplane racing, which is basically a very lightweight boat with a couple of sponsons, and the engine the propeller turns very, very fast, like 10,000 RPM. They use either V12 engines or turbine engines, gas turbine engines from helicopters, and those boats can go up to 200 miles an hour on the water, which
Wait a
on the
minute.
water is really fast.
Yeah, did I hear it correctly that they spin at 10,000 RPM, the actual propeller that is in water at
Yeah.
10,000 RPM?
Yeah, they don't last very long. They maybe last a few races. They're all custom made. They're all custom milled and machined, and they're very sharp. And what's really interesting, and this was explained to me at a meeting, you actually have the same horsepower in a tugboat, but that engine turns very slowly and turns a very large propeller to have a lot of force to tow or push something. Take the same horsepower, but spin it. So that big propeller in a tugboat might be only turning 100 RPM, maybe less,
Okay.
as opposed to our 10,000 horsepower propeller, which is going very, very, very fast to make that boat go really, really quick. So that's just really interesting. So people talk about horsepower, but it's like, okay, how is the horsepower then applied to the work that's being done is the other part of the equation.
Yeah, David also brought out a very interesting point is that you can have all the horsepower that you need even in a pencil if you can spin it fast enough. So torque matters far more rather than like just the blank horsepower number, because again, if you have a lot of horsepower and then you have to gear it down to use it, like let's say a truck engine that could have gears as ludicrous as 18 steps. That's like so like what's the actual benefit at that point in time? You do have quote unquote horsepower, but like to have it usable range, it's like tuck 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 keep going it down. So and I
Well,
think
like in where you are, lots of motorcycles. Motorcycles, because of their design, have to have relatively smaller engines, right? But they turn very, very, very fast.
yeah,
They're very high RPMs. That's why they're very loud.
yeah,
That kind of real high, shrill, loud, because they're turning 8 or 9,000 RPM
yeah,
to produce the horsepower they need to propel the motorcycle. One of the things that I like about the CV engine design is that we get the power at significantly lower RPMs for the same displacement. So it's a lower speed engine, which is actually really, really helpful in just preserving everything, because the faster you turn everything and spin everything, the more likely there's wear and risk of breakage and such.
Yeah, one of the best aspect of CV motion design is that cylinder wall, and piston heads, and basically cylinder head, all are copy paste from all other designs. So we do not have to re-engineer a new thing from scratch. Which again, many people have tried to make new engine, but most of them fail at sealing, because again, that cylindrical shaft and stroke that we have, it's very fine tuned. It has been fine tuned for 1 century. So it's like it's unlikely that you're going to develop something that seals as good as that. And I think this is the true genius of Ron, that he did not touch those things. It's like, yeah, we do not have to touch those things. We do not have to start spinning it like a Wankel system or something like that, where it's like, how the heck you seal it? Oh, you don't. You just hope for it. So this was a very good idea. And the fact that the actual transmission of torque is so efficient, having 3 elements of transferring torque rather than, so you have pin A, then it goes to teeth, then it goes to another pin. So that is a really wise approach of, basically, we need torque, right? We do not need RPM. Any of you who are familiar with basically electric vehicle, especially with Tesla, you know that Tesla motor is stupid in terms of RPM. It crosses 20,000 RPM. It's so stupid. And like, to give you a context why I'm calling this RPM stupid, is that there is no bearing manufacturer that makes bearing certified for that. So what they had to do is get to SK Hynix, and they're like, hey, how can we do that? It's like, okay, this is our the most expensive bearing, look into it. And then they have extended section, open the seals, spray oil into it, and hope for the best. So you can understand that high RPM sounds cool. It's like, oh, 20,000 RPM, 50,000 RPM. But like, if you are coming from an actual useful point of view, that's like dumb. You do not want that. If you want your things
Right.
to last, your bearings to last, your seals to last, you want to have lower RPM, as low as possible. So, and I think you guys have.
Yeah, that's what I was saying. That the fact that we turn just so much slower to get the same output is a big part of durability. That's why big diesel engines that do a lot of work, like in trucks and stuff, they don't really have to turn that fast because they're applying a lot more torque. You were talking about the linear application of force from the piston to the link rod and onto what we call our rod rack. If you think about, if you're going to push a person, right? So I don't know if you can see my elbow on camera. I'm not sure which way I need to move to do that. But if you're going to push a person, if you think about the difference between the crankshaft design, where in many cases, for most of the stroke, there is an angle between the connecting rod and crankshaft, right?
Yeah.
So if you're trying to push a person and your elbow is bent, and I try to apply a force to you, I'm not very strong. It's really going to be hard for me to push you off your feet. But if my arm was straight out, and then I pushed you in the chest with a straight arm, where my arm was all locked together into my shoulder, I would be very strong and very powerful. And so that off-axis motion of the crankshaft design is very inefficient. You were talking about cylinder wall positioning, where we're going straight up and down that cylinder wall. There's no off-axis motion, so we're not scraping against the cylinder walls. And when the piston's on one side, there's a gap on the other side, and that's where we get that engine blow-by. And that's where you have all these engine oil contaminants. Is the byproducts of combustion are contaminating the oil, and that's why you have to change your oil so often. Our engine is a sealed case. It works much more like a transmission. Well, how often do you have to change your transmission oil? 50,000 miles, 100,000 miles, because it never gets dirty. It gets worn, but it doesn't get dirty. So as the viscosity drops, you might have to replace it. But it's not like you have to do that every 3,000 miles like you do with a car.
Yeah, that's a very genuine point. And I think you also have experience with wet seals that go in the boats, in order to where you have propeller shaft crossing the hull to the outside. And again, having that higher RPM, I think that makes that far more difficult compared to a shaft that is spinning at lower RPM, right? Is that so? Yeah.
Yeah, well, what happens on the propeller, when the propeller spinning so fast, there's a term called cavitation, and you get all these bubbles forming on the surface of the propeller, which is very inefficient. And so they try to optimize that design, but like I said, the slower you turn that propeller for the same horsepower, you're going to get a lot more. You're going to get a lot more torque, a lot more power. The bottom line is, what kind of work are you trying to do? What kind of job are you trying to do with the engine? I think that when you look at this from the standpoint of application, I think the real key here is that the hope and promise of an electric vehicle is not having any emissions. The problem is, if you look at it from a global standpoint of what goes into making that battery, raw materials, the mining of those materials, and the waste products made from both manufacturing it and from disposing of it, it's actually a very dirty technology. The way I see what we have is, I think it's a transitional technology, meaning at some point someone will figure out the battery thing. They'll figure out energy density and all that, and hopefully get to a materials design that's not so polluting. But when you combine things like range anxiety, and there's a lot of things that just batteries don't make sense for, right? Like you're not going to use batteries in a ship that crosses the ocean.
Definitely not.
That's just
Definitely not.
completely impractical, right?
Yeah.
But those ships put out a tremendous amount of harmful emissions because they're burning the dirtiest fuel possible, bunker fuel, which is basically so sticky and goopy that they have to heat it to thin it out enough to actually burn in an engine. So when you could have our engine burning anything from liquid natural gas, which is going to be much cleaner. I think that's the other thing. We are a multi-fuel application, and I think most people are familiar with dealing with gasoline, petrol, diesel. Maybe less familiar with burning gaseous things like like hydrogen, like methane.
Methane, we are familiar with that because in India, it's very common for CNG vehicles. So CNG is methane, majority methane, some amount of ethane mixed there, but majority is methane and some amount of contaminants. So we are kind of familiar with basically methane burning. Gaseous burning is quite easy in India. It's like we are already used to it. Although when
those are fast burning fuels, right?
Definitely.
They can combust fast, and in a conventional engine, you have a lot of emissions because the fuel charge needs to have a long duration to push the piston down to get the crankshaft action to take a rotation. With our design, we actually perform much, much better with a fast burning fuel. This is one of the things that Ron impressed upon me that I always thought was really amazing if we could make that work. So if you could take a clean burning fuel like hydrogen, a conventional engine actually really struggles with fast burning fuel. It's like if I consume all the fuel at the top of the stroke, I don't have a lot left to push the piston down. And especially in the early designs, those engines basically shook themselves apart because they just did not run smooth. But on something like hydrogen, where we could combust very early and quickly and get our full stroke completed, that's why we have very, very little emissions, because everything is already consumed before we get to the exhaust part of the stroke. So I'm really excited that whether it's cars, trains, buses, ships, that I think we can check the environmental box. I think we can check the greenhouse gas emission box by eventually moving to a hydrogen-based fueling system with our technology really optimizing that fast-burning fuel. I'm seeing companies like Yamaha, which is an outboard engine manufacturer, just came out with their hydrogen outboard. Toyota has hydrogen products. I think that what's happened in the transportation industry is everyone's trying to find the technology.
Yes,
and I believe that there are opportunities for multiple technologies, one of which is, and I think, again, I want to go back to Ron's design. We have this hollow power shaft that runs through the unit. And what that allows us to do is to have multiple units on the same power shaft. So, for example, if I'm running a big truck and I need a total of, let's just say, 500 horsepower, but I only need 100 horsepower to keep the truck rolling down the road, I can electronically clutch in and clutch out multiple engine units. So when I need to get up to speed or go up a mountain pass, I can use all the horsepower I have available, but I can declutch and de-energize those engines when I'm just trying to roll down the road.
Basically, empty truck versus loaded truck. If you have empty truck, don't use the maximum engine power. When you have like loaded truck, you can have that. Yeah, that was
I can do that with a ship in a harbor. I can de-energize. But here's the other thing. I can have different functionalities on the same power shaft. So I can have a fueled engine, I can have what we call an air motor, and I can have a compressor. So I could run my engine, I could compress air, and then I could use that air to be the force on the piston to drive the motor. We've actually conceptualized that design for the drone market, that you could fly a drone in on an engine, if you wanted it to be quiet, if you wanted it to be low thermal signature, you could switch over to the compressed air engine. It would be very quiet. And then if you needed more time on station, the drone could fly off station, power up the engine, compress the air again, refill we'd use the fuselage as the cylinder, and then bring the drone back into the, we'll call it the battle space or the observation space, depending on its use. And so I think there's applications that are unique to CV Global and the CV engine design that just are not replicatable by anything else.
Oh, definitely. Like one of the AHIRAVAT's branch is with a drone market, and we have specifically ordered, like basically the people we are working with, they are very excited with the fact that because it's a hollow shaft, we can have propeller at the back, we have the engine, and behind it we can have the motor. And so benefit is that most of basically we take off on battery, because again you do not want to give hearing damage on soldiers. So you take off on battery, then you fly. Once you are high enough, let's say 10,000 feet, you use your engine, it's barely audible at that point in time. You fly, and when you need that dead quiet thing, you use electric battery system, which again you do need giant batteries for surveillance equipment. They do consume a lot, especially if it's any type of active radar, it's going to consume a lot of power, or even LiDAR, they also consume a lot of power. So we have batteries, and then because we have hollow shaft, we do not need giant mechanism or transmission. It's just a shaft. We just have a latching clutch. It's like latch it to motor or latch it to basically engine. And again, it's a very unique thing. And I think Ron was showing off and he's like, hey, we can make it hollow. I'm like, yeah, you're showing it off that you can do that. It's a very what you call new desirable thing, because electric motors, most of them are hollow shaft. Most of them have like axle literally going through it. Most of them do that. So nowadays. So that's,
and on our website, we show in part of the video, we show a fuel engine connected to an actual electric motor, so that we can actually have that hybrid as part of actually the same unit. We're not having kind of a fuel engine over here, an electric motor over here. They're actually part of the same.
Yeah, that's the dream.
Design.
Yeah, that's the dream, because inherently engines are ludicrously efficient. We have once we started to work on engines, we realized engines are measured not by miles per gallon; they are measured by BSFC, brake specific fuel consumption. So it's a unit, basically how many grams of fuel you have to burn in order to get 1 unit of power out of it, basically 1 kilowatt hour. So best engine that we have, that's on like giant marine engines that are 2-stroke, 30 megawatt rating. Those are the best in terms of efficiency, not in terms of emission. They are ugly as hell. But in terms of efficiency, like how much chemical energy you are converting, they achieve as low as 150 grams of fuel combust for 1 unit of power. To give a contrast, the best Toyota engine I have seen, that only goes to 200 grams. The best 4-stroke diesel is around 180. Best 2-stroke diesel reaches a little bit less, like 175. Once you start to scale it up, then you can go much higher. Now, here's the deal. If engines are so efficient, why our mileage is not that great? Turns out that engine do not like to change. Engines are like a base load power. They are like, hey, put me at this RPM, put me at this torque loading, do not change it. But again, the moment you are driving, it's not fixed condition. You have takeovers, you have to slow down, you have wind resistance, you have going up a gradient, coming down a gradient. So that's why we are also working with energy partners, basically people who are going to provide us with awesome battery technology. So we can have engine running as base load. We do not just like start, go to base load, do not have variable valve timing, do not have this or that. Just go to your sweet spot or peak BSFC, feed the power into battery. If we need more than that, battery will discharge. If we need less than that, battery will charge more. And again, that also allows to recover from regen. So that way we can give the best actual real world, not like, in optimum condition this can do that, but you will never get that in real life. No, if we want to, let's say, make it 30 miles per gallon, or like, what is your vehicles right now? What do they give roughly?
Yeah, my car gets on the highway 28 miles per gallon.
Let's just say we said 35 miles per gallon. I want to be damn sure that is 35 miles per gallon. Not be like, okay, in perfect condition, nobody's on the road is like smooth like a tarmac, it's like, chill about it. No, in real world, because again, not only we have battery to smooth out the load on the engine, but regeneration also allows us to recover some energy. So that way we can actually give best of both worlds. And people at the end of the day want power. Thankfully, electric motors are one of the most powerful things. And again, anybody who have worked with diesel locomotive, no, like you cannot go more powerful than that. It's like, we good, bro. We good. We got this. It's just the battery part sucks. Motor is like wood. We sorted. It's just the battery is not there yet, so to say. It's not there yet. And again, because we have an engine or quote unquote range extender, we have the benefit that we do not need giant batteries. Just like keep it small. Keep it light, keep it
And I
compact.
think that's a great point. That's where I was going to go. That I think the best operation here is to size down the engine and to size down the batteries. So instead of having this incredibly heavy battery pack, to be able to get all your transportation out of the battery, you have a smaller engine, and part of that. So I think one of our best applications is as a range extender.
Yeah.
But I can get the battery pack smaller, and part of my engine's work is to refill the battery, because I think the impediment to EV sales is always going to be range and recharge time. Now, I know they're working on technologies to get the recharge time much lower, much closer to a like a fuel fill. But I think the range extender concept is really what more people would buy. And we can do all the theoretical conversations we want, but what it comes down to is, if we want an OEM to invest in our technology, then they need to see a market. They need to see a consumer, either a individual or a business, that was willing to do that. So, like, how is it appealing to a shipping company, right? How is it appealing to somebody who manufactures motorcycles? How is it appealing to someone who manufactures, diesel electric locomotives? I know here we have diesel electric ferries, and the generator part is like 2 stories tall. It's gigantic,
Damn.
but it's much more efficient to use the engine to power the generator than to use the engine to power the ferry.
Yeah, direct coupling is not efficient because engines like to stay in that sweet spot, efficiency island,
Right.
and you can't stay there. And there is another aspect of it that people kind of forget. And again, our talk with Rajendra Sharma was very fruitful in this regard. Let's just say, and he's working on a capacitor, and he has a capacitor under construction that is quantum capacitor. Let's just go with that it will solve all your problem. But here's the deal. Where the hell you will get the power to pump into it? It's like people talk about, like, let's say Tesla semi truck. It's like, we're gonna charge at 3 megawatt. I'm like, do you understand what 3 megawatt is? It's a small city block. It's not something that you can just like, oh, middle of nowhere, village, nobody is there, we have 3 megawatt there. I'm like, bro, that's not even a plug power. That's like, you require what we call high tension line. I think you guys call it high tension line, 135 kilovolt. Then you have to step it down. You need a mini substation to step it down. Then you can feed it. I'm like, who is paying for that? Who's
I
paying
read
for
it. I read a great statistic. This was for Canada. If Canada replaced all its over the road heavy trucks, 18-wheeler type trucks, just Canada, to charge those trucks would require the entire energy output of the entire Canadian electrical grid.
Definitely.
There would be literally no power to charge to power homes and businesses and lights and everything. All that power would have to go just to recharge those trucks. So I think there's a lack of realism, to your point, of what it actually takes to do this. It can't be 100%, because then we'd have to build so many more power plants and have so much more infrastructure. So I think that's the thing that the world is trying to figure out, is what is the right mix. But I think what's kind of, I'm biased, but I think what's great about our design is that I think we fit a lot of these applications depending on whichever way somebody wants to go, whether it's a direct drive, just the engine itself, whether it's a hybrid, whether it's a combination of multiple units performing multiple functions, whether it's a range extender. I think it's really flexible in that manner. And a lot of times we all tend to think about things that roll down the road, but there are applications of engines, for example, generators, both in personal use, military use. I like to use the military as an example. They have to fly everything everywhere, right? So if I need a certain amount of power output in a battle situation, if I could make that generator produce the same power in half the size and half the weight, I can double the number of generators on the same pallet that I put into a C-130 aircraft, or I could have more cargo room for other things, right? If I'm burning less fuel to keep that same power output, I have less fuel supply convoys going out, putting less people at risk to deliver the fuel to keep those things going. And so if I'm on a train that's transporting fresh food and I have those air conditioning units on top of the trains, do you know how often those trains actually have to stop to refuel those refrigerating units?
Yeah.
They actually have to stop in the middle of nowhere and refuel those refrigerator units. If we could extend that duration, so there's a lot of applications that aren't transportation based that still have a tremendous amount of room to improve their functionality. And that's what I'm so excited about. I see some of our competitors, which I won't name, but they're like single application. They don't really go in a lot of different directions. They just kind of do one thing. And I think the flexibility is what gives us a lot of marketing advantages.
Oh, you talked about a competitor. That just reminds me. Right now, there is this company known as Tesla. You may have heard of it. So they makes a electric, semi. Here's the funny thing: people just caught a camera photo of it. It's like a Tesla semi is being pulled by a Peterbilt. I think that's the truck company name, and that's a diesel truck. I'm like, you can't actually drive your own system on your own load, and how do you expect the world to rely on that? Like again, and there's this company on Canada that they are doing this like amazing thing, and again, hopefully we will also work with them. Is that they have series hybrid? Basically, they have an engine driving a generator, generating powering the batteries and battery system, and they come up with a very realistic number. It's like, again, if I say 2 megawatt to you, it's just a number. But anybody dealing with electrical side, they will be like, bro, 2 megawatt is not just something you can, oh, 2 megawatt, who cares? It's like, that's a transmission line. So he specified something very unique, is that whenever you're talking about 10% fuel efficiency gain on a diesel truck, that's like removing one car from the street. That's one truck. If you just increase it by 10%. And people don't understand, like our cars most of the time are static. They are sitting there, they're not doing much. You just go from office to home, home to office, and home to school, back and forth. It's just like most of the time it's off. Trucks are completely different. They are running 24 into 7. Heck, some scenarios they have multiple drivers, so they can keep running 24 into 7. So if we can save even 5%, that is like night and day difference. So people are like, oh, why not electrify? It's like, first you have to understand that megawatt is not something that you can have. It's not a conversation to be had where it's like, oh, we're gonna have like 10 megawatt station. I'm like, that's a small power plant.
It's just not realistic.
Yeah, it's like,
You go back to the trucks for a second. I tend to think about it at the individual trucker level on one end, and then the fleet level on the other. The average trucker in the United States is often an individual owner operator. Obviously, his fuel cost after his truck and maintenance costs is his biggest expense. If I can cut that trucker's fuel bill in half, it changes his life.
oh, definitely.
It changes his family's life.
Yeah.
His business is much more viable. Right now, I take that all the way up to the fleet level. If I go to Federal Express, UPS, anyone who has many trucks, any of the big trucking companies. Now think of the fuel savings in the many millions of dollars of burning, again, half the fuel cost. What does that do to the bottom line for those companies? So whether you're an individual or a corporation, everybody's so obsessed with batteries, but the reality is this is the technology we have now.
Definitely.
And if I'm burning half the fuel, I'm putting a lot less emissions into the air by default. Yeah. So I get to check two boxes at the same time. And I really believe that, especially when you look at a big truck, there's plenty of room under the hood that if I want to maintain a drive engine with a range extender engine, and I want to have some battery activity. So, for example, if I'm parked in the city, offloading my truck and wheeling the goods into the grocery store, and I don't want to sit there and idle to throw out a lot of emissions to keep the refrigeration running, I can switch to batteries for half an hour. And so I think instead of looking for one solution, I think we need to be looking at elegant integrated solutions that combine these multiple technologies. And what I like is that we can deliver that all in one package. All my point about talking about hydrogen or CNG or whatever is just simply that the efficiency of using some fast burning fuel with an engine that can actually take advantage of the speed of combustion provides a tremendous amount of advantages, especially when it comes to emissions.
Oh, definitely. For Indians, it makes a lot of sense simply because we use CNG. We have the pipeline sorted. Like that's the best part for us. It's like we have the pipeline sorted. It's not like, okay, where are you going to refuel it? It's like, bro, I have right there. That's sorted part. So
you have CNG fueling stations right there.
Yeah, it's done. It's sorted.
The cleanliness of the battery when it's doing its job, but how did you get the power into the battery? What fuel did you use to make the electricity? Now, if you did it with wind and solar, then I'd say, oh, great, right? So if somebody has solar panels on their house and a charger in their home that charges the car, I'm like, awesome, super green. But if you tell me you're burning coal to charge to make the electricity at the power plant, and that's what you're putting in your battery, I'm like, you just went like this, like, oh, I don't really know, I don't really care where it's coming from, but you just mined and burned coal I'd rather have it come out of the tailpipe. At least there's a catalytic converter to clean it up, right?
Yeah, it's the same saying, like, out of sight, out of mind. You can't see it does not mean it
Right,
does not exist. It's just like
right.
out of sight, out of mind. So yeah, that's a very genuine point. That's why I keep like bringing things down to the brass tacks, so to say. And that's why I'm like so excited about series hybrid, because it gives best of both worlds. And it gives time, basically batteries time to mature, charger infrastructure to mature, grids to turn into renewables. It gives
They're
them
getting
time.
there. I mean,
Yeah,
the
yeah, of
battery
course. It's like
technology, they're looking at the different chemistries, they're looking at different materials, they're getting the charge times. China is very good at that. They've really made some really big advancements. I think it'll get there,
not there yet. Let's
but
just.
it's not there yet. I think it's going to be a while.
Oh, very
And
long while.
again, you have to look at yeah, you can change the technology, but what are the materials? What are their availability? What is their cost? What is the environmental impact of that? And the disposal side, right?
Okay.
We have all these batteries. Where's this stuff going? Is it renewable? So I want clean air, just like everybody else. I don't want to die. So part of this, and I'll have to wrap up here, but the reason I got into this originally was I thought it was very cool technology for cars and trucks and transportation, and less emissions and less fuel consumption and such. But I really feel that in so many applications where we're literally changing lives, where we're saving lives in the military, we're having those truckers be able to have a better family life. And if a family is just spending less, just a regular family is just spending less money on fuel, or ultimately, eventually, maybe no money on fuel, but certainly a lot less, that allows them to buy more food or have their kids be involved in another activity. So I think, I know that might sound a little bit of Pollyanna, but I really believe that, part of our job is not just to make money, but to improve lives. And I think that's where we really, that when we're not talking about incremental, microscopic improvements in fuel economy. We're talking about significant changes in fuel economy with the commensurate reduction in emissions and getting the mechanical benefits. If I have a much lighter engine, then all of my subcomponents of my vehicle, for example, can be lighter. Now the whole car is lighter, the whole truck is lighter, which means I can use less horsepower. So it's all kind of wrapped in a nice little bow that way. I think there's a whole cascade and chain of benefits when you reduce the weight of something, you reduce the physical volume of something, reduce the fuel consumption, reduce the emissions. I think the technology that we have developed is really I think it's really is still world changing, and I don't think that's hyperbole or grandiose. I think it really is that.
Okay. So I want your final snippets is basically give me a summary of Ron. I want to understand how Ron appears to you. So give me a summary of that.
You earlier you're talking about Ron's back. Ron's a very humble man. He probably told you that his dad sort of put a challenge out to him that, boy, if we could eliminate the crankshaft from the whole equation, what would that do? And most people were like, yeah, that would be great, and then they would move on. He spent years and years and years thinking about it and working on it. His ability to conceptualize things, I've actually watched him work on the computer and just change things in real time. His understanding of engines and of the just individual components and to just design something from scratch. And over the, I think, 8 or 10 years that I've been working with him, to see him make all these improvements and refinements literally out of his own mind is really impressive. And I think sometimes he probably doesn't know how much we really respect him, and how all of us at CV Global really want to see his vision that started so many decades ago really come to reality and come to fruition. We want to kind of really deliver on that because we've all been impressed. We really believe in the vision, and I think sometimes it's hard for an inventor to get that product to market, get it from the invention stage to the scaling stage. So I think when it comes to myself or Brian or David, I think that's where we're coming from, is we all talk about that we really want to see this, and I think we're getting really close.
Yeah. So thank you for this amazing interview. This was quite an eye-opening, and I wish you and us best of the luck, because again we are working on it. One tiny question: have you seen the AA1 engine, the first prototype engine? Have you seen it running?
I was there when it fired up.
Nice. soon we'll have few more of those. So we're gonna have that again. Anyway, this was
Excellent.
amazing. Thank you.
Thank you. I
So
enjoyed it.
okay, thank you so much.